Okay, this is your hybrid lecture this week. We're going to talk about chapters 7 and 8, digitizing and geocoding. We're not going to spend a whole lot of time talking about digitizing, and I'm going to cut through geocoding fairly quickly as well. And then we'll look at the exercises in class next week. I want you to try to do everything that's assigned for these chapters at home. But don't get wrapped up in whether you can complete it or not, because we'll take time in class next week before our lecture to work through this stuff to make sure that we're all on the same page. So, quick overview of what is digitizing and why we do it. It's a way of making new maps or map features that are wrong, or add missing features, or just to create features or to edit features or to change features. So the way we used to do it was something called an overhead or a heads down digitizing, where you would have a scenario like this where you'd put a map down on a digitizing table. You have this thing they call a puck with a little target on the end of it. That was controlled or hooked up to a computer somewhere, where you would line up the little crosshairs on the points, like the control points being the corners of the map, and click in on those points and tell the computer what the coordinates were. And then after that, you would literally just go around and make all the connections that you needed off of that heads up display, or heads down display rather, and it would then begin to record those coordinates and make those conversions and convert that paper map into digital form. Then along came heads up digitizing, which was what we're more likely it's a more accurate description of what we do now. And basically this is where, instead of looking at a paper map or a photo on one of these digitizing screens, it's looking at a aerial photo on a computer screen along with some other referenced object, like another data layer, that allows you to then see how things are lined up and or make things that line up. So it could be, use this sort of thing to get something where it's supposed to be by changing it, or it could be something like I need a polygon on the football field, so I bring up a geo-referenced aerial photograph, and then I simply go around that photograph and digitize it on the edge of the stadium. Editing features is the other big component of digitizing. You can do things like move. An example here, you can see that the blue outline on the left is not exactly where it needs to be, and you can select certain tools within the options on Pro and then simply shift everything over to where it needs to go. You can also rotate things when they're not lined up properly. You can add extra vertices if you need to. For example, here we have this building that's sort of a backwards shaped C, but the edge detection algorithm, for example, that we use to identify this structure in remote sensing, just identified it as a square object, and we had to take that front part of the building and add some vertex points and then move that back to reflect that area in the building where there is no building, that gives it that unique shape. We can also use to split features apart, so that instead of having this big, long, massive looking mess of a polygon, it turns out it might actually be quite a lot of several little polygons. And then we can go around and trace things as well. We can create new points, point features. We can create new polylines. Again, these are very similar to the same things you would have done in, for example, in GIS 200. And those of you that are taking class now are very familiar with this. The rest of you, if you haven't done this before, you're going to need to learn how, and the way you're going to do that is by going into Pro and learning where these tools are and how to use them, and that's what the exercises are for. You can also create polygons, and we have various cartography tools as well. So you can generalize and smooth, and so you can make a sort of jagged looking thing, but if it's really got a rounded edge, instead of making all those lines smooth, you can use a function to sort of create more of a polynomial-like line as opposed to a linear feature. We can also bring in things like CAD files and utilize information from that to identify stuff that we are interested in. We can transform features, bring them together. Alright, that was pretty much all of Chapter 7. That's why we combined this chapter with Chapter 8, because it was really short. Chapter 8 is on geocoding, which is basically converting an address into a point coordinate location. So it's the process of creating geometric representations for locations such as points from geocodes such as street addresses or zip codes. Fancy way of saying it's turning addresses into points. The computer uses a program called a geocoding engine that employs code tables and rules to standardize address components and then carry out something called fuzzy matching. Now, basically what all this means is it breaks down the components of an address into different parts. The program then analyzes the individual parts in a specific order, in a specific way, goes down through a set of known locations that are organized in the same fashion, and it creates a most likely match, a fuzzy match. It's not a 1 or a 0, it's not a is or is not. It is more of a how good is this match? Is it 80%, 90%, 95%, 99%, 100%? And once it identifies a number with that, then you can determine whether that in fact is the correct address or the correct location for that address. So what are some examples? Surveys, visitors at an arts event. So people, you're having an art show, you want to know where your audience is coming from, so you can target advertisements, or maybe you've just got the list of people who bought something and you want to target sales flyers in those areas. It's really simple. You have them to sign up through some sort of mechanism where they provide you with an address, and maybe it's just zip codes that you're interested in. So you map zip codes to determine where to focus these activities. Hospitals can use this to see where patients come from, to figure out if they need satellite or clinic offices. For example, if you have an ER that gets a lot of patients, you might want to map where they're coming from and then try to determine the best spot to open an urgent care facility. Store chains, they map stores and customer locations compared to the maps of their competitors to try to figure out if there's opportunities to expand and inhibit their neighbors, the neighboring or competing businesses. And there, of course, there's always other examples as well. So here's what the tabular data would kind of look like. Here we have some street addresses and zip codes. And if you just look across from left to right, you got the object ID, you got the street. For example, 272 Dithridge Street. The name is Intercultural House. Zip code is 15213. Okay. You can also have geocoding reference layers, which is sort of what you're matching to, if you will. And we have two basic types we're going to look at. The first is street center lines, which essentially go down each street, know what the street's name is, and then based on the address, it tells you how far and where to move down the street in which direction. Then we have zip code polygons, which basically is a polygon that identifies every mailing address or physical location that has a mailing address that is in that zip code. So the method to map data, whose geocode is for a polygon, you assign each record to a polygon, you spatially join the count to the records, you symbolize it using blah blah blah. None of this really matters. What matters is that you have the ability to identify the features, the tabular data. If you have the address data in table format with other information and you geocode it, you now have it somehow assigned to either a polygon or a line or a pointer, depends on what it is you're doing exactly. And beyond that, how you join it, it's more or less up to you, and how you symbolize it. There's nothing extraordinary about choropleth or graduated point symbols. There's lots of ways you could utilize this data. This just happens to be more of what they're doing in the examples in the textbook. Zip code boundaries is just a map showing that you can see how they're kind of set up. And you can geocode points at the zip code centroids, for example. And so every polygon you identify a centroid for that zip code, so you could do it that way and match things up according to that. And then you could, in this example, do a spatial join, so you could figure out whatever it is you're looking for and get the counts and map things out. Now, when you're looking at linear geocoding along street center lines, you use basically a 4 street address numbers, low to high for each side of the street segment. So what are the address components and what does all this mean? The first thing is the number. For example, if your address is 125 Oak Street East, Apartment 2, Pittsburgh, Pennsylvania, 15213. First thing it looks for is the 125 because that is the address number. Then it looks for street names and street types. And so it could be lanes, streets, boulevards, routes, etc. Street names would be things like Oak, Cattail, Cherry Blossom, and any other sort of crazy name you've ever seen for a street or road. So in this example, it looks for street names and it finds Oak, and then it looks for street type and sees street. Then it looks for either direction suffix or direction prefix. East on either end, East Oak Street or Oak Street East, for examples. It looks for a unit number if one exists, like an apartment. And then it looks for a zone or a city, like Pittsburgh, or a zone and a zip code. In other words, the zip code for Pittsburgh, 15213. And once it has these things, that's really all it needs. So intersections, put street intersections in address field, do not include street numbers. Forbes Avenue, so 399 Forbes Avenue and 100 Craig Street is an issue. And so you would not want to add it like that. You would want to use things like connectors. But you need to be consistent, like Forbes Avenue and Craig Street, Grant Street and 5th Avenue, East North Street Road and Duncan Avenue, for examples. How does this geocoding flowchart work? Well, as most flowcharts, if you don't understand what you're looking at, they don't mean a whole lot. So we'll try to explain it here a little bit. You input your address, you parse the address. Parsing the address means you break it apart into these individual sort of things. And then it generates something called a SoundX key, which is kind of the programming things that we're not going to worry about. And then it finds candidates and identifies, how well they match or not. And that sort of loops you around to the other side. So the first 2 boxes are pretty understandable. The next 2 you really don't need to worry so much about because that's not the kind of thing, at least to the extent that we're going to be talking about in class. So once you identify matches, and once you have matches and you put it in an address, the question is, does it match or not? If it does, you get a score, and then you look at the score, and if it's above, say, 90, then you say, yes, this is a legitimate address, a legitimate match, and it goes into your outputs. What happens if it says no? Well, if it says no, it's an output where there is no match. If there is a best match that is not up to the level that you're looking for, then it also is a no, and it goes back into this other box. This other box is the box of addresses that you have to check and try to fix. So here is a slide that is going to be really hard to see. You can see original address 125 East Oak Street 15213 in white font on a light gray box on a white screen. Way to go, Esri. It's like they never took any of their own cartography classes. And so the address is parsed out. It breaks it up in segments, 125 East Oak Street and then zip code. It standardizes the abbreviations. So East becomes E, Street becomes ST, for example. And then the individual elements are assigned to matches, and it just has its own way of doing that. None of that's really that important as far as what you need to worry about. And then ultimately it indexes the values and says, yeah, okay, how close are we to this? How close are we to that? And it matches names on the basis of how they sound or translates, and it tries to do this. Again, all this is really interesting and clever, but it's not real practical. As far as geocoding goes, you're just going to try to get your data set in the right format and then use a geocoding tool to run it. And it'll go blah 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 blah, and it'll spit out some sort of product. What does that product mean? Good question. You can also get scores, like I said earlier. So it uses a rule base to source the scores and references matches. It starts with a score of 100 and it takes points away for every mismatch. And it uses rules like sounds like, street names but does not match, is missing in the source or doesn't match, and it takes certain points off for certain things. And ultimately that's how it scores everything. So here we have candidates that are identified for our 125 East Street that we were looking at earlier, and so this just sort of goes to show you how the different candidates are and how they're scored. Again, interesting, clever. You should see it and you should contemplate it, but don't worry about it beyond that. And so eventually it just matches a point. And what you can see here is you've got this Oak Street and you got Pine Avenue coming together, and at different points on the street we know that, for example, at that node where Pine and Oak intersect, that is 100 Oak Street, and at the other end of the street it is 198. I want to point out that on one side it's odd and on one side it's even. Okay, that is important because typically one side is obviously going one direction, it's important because it tells you which side of the street it's on. If it's an even number, it's on the left. If it's an odd number, it's on the right. And so you have 125, which is an odd number, which would be on the street. And this is literally like looking at a distance number from 101 to 198. And so at 125, that's sort of where it's at. So let's look at street address locator styles and see how some of this stuff looks. Alright, so we have food sources and we geocode it to the streets, or we have spatially joined data that we've geocoded to neighborhoods, and we spatially join that to block groups, for example. What are some of the problems you can run into doing something like this? Variations in street names can create problems. Data entry, 5th Avenue instead of 5th. Sawmill Run instead of a Sawmill Run. These are all things that can create problems. Place names instead of addresses like White House or Heinz Field or the Empire State Building can also create problems. Big old chubby fingers like mine hitting the wrong key when you're putting stuff in will really mess it up. Same street, multiple zones. Maybe you have a main street south. Maybe you have multiple main streets and they're different zip codes in the same data set. That could be a problem. For example, if you're dealing something with here in Northern Virginia and you've got people that live in Sterling and Ashburn and Chantilly and they all live on Main Street and they all might live at 100 Main Street, but they would have different zip codes because they're different communities. P.O. boxes. Yeah, that could mess you up because you don't have a street address. So what are the solutions? Clean your data before you geocode it. And the way you clean it is really pretty simple. You take your address, you try to parse it out into these different segments. There are functions in Excel to do this with if you're interested. Once you have your data parsed out, spend some time sorting all your data by each column so that things that are similar are together, and look for the odd thing, like if you've got White House, White House, White House, White House, Whit House, change the Whit House to White House, that kind of stuff. If you know all of the addresses are in a particular zip code and you see one zip code is different, change it, fix it, make it like the others. And so it prepares a log file, and a log file includes reasons why addresses did not get geocoded. And so this tells you what was wrong, and you can use this to go back after you run the geocoding engine to fix things. So process should work like this. Set up your data, clean up your data, fix your data as best you can, run the geocoding engine, see what doesn't match, try to identify the reason it doesn't match, and try to fix the reason it doesn't match. Sometimes you can't fix it. Those are just addresses that do not match. There's nothing you can do about that. U.S. Census tagger lines are digitized from 1 to 100,000 scale maps. The good thing about the tagger lines is they're free and they're easy to download. They're uniform across jurisdictional lines nationally. Street addresses formatting works well with standard GIS geocoding capacities. It's the simplest and easiest way that you can do this. What are the cons? Incomplete data. The placement of address points is approximate, so it's not necessarily going to give you the exact location. Tagger line attribute table will look something like this, and the census street lines are extracted from lines that make up the census boundaries. The MAF/tagger, the master address file, or the that goes along with the topologically integrated geographic encoding and referencing, is basically this complete inventory of housing units and businesses in the U.S. and its territories. And a tagger is a collection of line data. The MAF is used to produce these mailouts that the census uses in forms. And for the American Community Surveys, it sends out random samples. It randomly pulls addresses from this. But MAF and tagger can both be used to produce maps for on-ground census takers. That's why this stuff is updated, because doing the census is a terribly important and terribly difficult thing, because roads and houses change all the time. They have to have ways to update this stuff, and so they keep these data sets somewhat updated. Tagger 2009 and newer has a more improved positional accuracy, so those are better data sets to use than some of the old ones. So the old tagger might look something like that, where the new would look something like this. U.S. Census zip codes, zip code tabulation areas, or ZCTAs. They are approximates for census purposes. They do not reflect actual zip code areas and are not kept up to date, so you have to be suspicious of that data whenever you see it, need it, or use it. Local jurisdiction and parcel address points. The pros of that is the accurate placement for residential locations are often pretty good. The cons is that usually you have to contact individuals and agencies to get the most updated stuff. Sometimes it's not available, sometimes you have to pay for it, sometimes it's not cheap. Sometimes it literally just stops when you get to the edge of a county or a city or a community, and because it is very accurate, these also tend to be very, very large files. Street center lines from local jurisdictions, potentially more up-to-date than some of the stuff you might download from census. They're often adequate accuracy to meet city infrastructure needs, so plus or minus 10 meters. You may need to find an individual within the agency to get you the best stuff. And then again, you're going across Fairfax County, you hit Fairfax City, big hole. So you got to think about that kind of stuff. Large areas, Geographic Commons Web Service uses tagger maps across the U.S. Esri Street Maps North America is across the U.S. and Canada. It uses the 2005 TomTom maps. They're more accurate than tagger. Esri Street Map Premium uses these other data sets here. Online geocoding is pretty prevalent. ArcGIS Online has a geocoding engine. But it requires an organizational subscription. In other words, we can do it, but it uses the Street Map Premium. It's available for 160 different countries. It costs about $4 per 1,000 addresses. Okay, so listen up. When you're doing your geocoding, we are not going to do any geocoding using ArcGIS Online. Don't ask. We're not going to do it. GeoCommons is another one. It's fast and it's easy and it's generally inexpensive and often free. However, when you do that, you lose the confidentiality and you lose the privacy that goes along with it. It has to be connected to the internet, and we're not sure how accurate it is.